What do, fellas? Welcome back to the channel. Today we're going to be going over project number 2 in the How to Get Started with Arduino series. So if you've not hit the subscription button, the subscribe button, make sure to hit it and hit the notification button to make sure you get notified when I upload my next video. So as said, we're going to be going over the project number 2 in the series. In this video, we're going to be going over a little bit more, or we're going to be going a little bit more in depth into the Arduino. We're going to be looking finally at the Arduino IDE, the Integrated Development Interface, and looking at how you can program the Arduino so it actually influences the electronics on the breadboard. So it's going to be very exciting. So without further ado, let's just jump into the project. How to get started. So for this project, we're going to be needing 3 LEDs. It doesn't matter what color the LEDs are. I've just picked 1 green and 2 red. You can pick any color you like. Then we need a switch. We need a 10k ohm resistor. We need 3 220 ohm resistors. We need a variety of jumper wires. Doesn't matter what length, as long as they fit for the things that we need. We need the Arduino or any other board that you have the preference of using. And we need a breadboard. So let's get to assembling. So like in the first video, we're going to be start by connecting the 5 volts Arduino to the plus on the breadboard and the ground on the Arduino to the minus on the breadboard. So we're going to connect the black wire here to the ground and the minus, and then the black or red wire, from to the 5 volts on the Arduino to the plus on the breadboard. Here we go. So now that we've connected the 5 volts in the ground, we need to connect the LEDs to the breadboard. I'll plug the LEDs into the breadboard. So as I also mentioned in the last video, the LEDs have a long leg, which is the anode, and the short leg, which is the cathode. The long leg, the anode, is where we connect the power, and the short leg, the cathode, is where we connect to the ground, so they have a full loop. So we're going to start by plugging the LEDs in, like so. Here we go. There we go. And as mentioned, we need to connect the output pins to the long leg so that we can control when the LEDs get the power instead of them continuously getting power like the last video. So we're going to connect the output pin number 3 here to the green LED. There we go. You can see here we have the connection between the number 3 pin here, to the long leg of the green LED. Now, we also need to do this with the other pins. There we go. Now you can see I've connected the output pin number 4 to the long leg of the second red LED, and output pin number 5 to the third red LED, and second red LED. So now that we've connected the power to the LEDs, we also need to connect the other side of the LED, the cathode, to the ground so we get a full loop. Here we take the 220 ohm resistors and plug them from the cathode into the ground on all 3 LEDs. So now you can see I've connected the ground from the LED to the ground on the breadboard. So now we actually have a full circuit. But even though we can control from the pins when the LED get power, we can also apply a switch to make sure that when we hit the switch is when the power is being driven to the LEDs. That will also give us some more control of when the LEDs will light up and which LEDs will light up at a certain time. So to connect the switch here, we just connect two of the pins into the breadboard, as so, and connect from the power to here to the breadboard, as so here to the switch. This is not long enough, and we take one of the greens. There we go, you see one of the switch pins is now connected to the power. And we also need to use the 10K ohm resistor to connect the other side of the switch to the ground. As so. But however, to read the input or the message from the switch, we also need to connect the output pin of the switch to an output pin on the Arduino. That way, the output pins that we need here to the LEDs are messages that we send to the pins that they need to light up. However, with the switch, we receive data from the switch when we press it, which will then we will use to light up the LEDs. It'll make sense later in the video when we look at the Arduino IDE. So we connect the output switch here, output pin switch here, to number 2 on the Arduino board. Sorry. Here we go. So you have the number 2 here to the switch. So now we've actually configured the board, done. We just need to jump into the Arduino IDE and finish coding the actual board. So let's jump right into it. Okay, so now that we've gotten into the Arduino IDE here, we're gonna first off declare a variable containing the state of the switch, meaning that if we press the switch down, it's gonna be 1, and if we don't press the switch down, it's gonna be 0. Since we start off by not pressing the switch, we're gonna start off making it 0. Next up in the setup function, which is the function which runs when the Arduino first powers up, is where we need to declare the pin mode function, which declares if the pins on the Arduino board either is an output or an input. For the Arduino switch pin, it needs to be an input pin, since we get the state of the switch if we press it down, which then sends data into the Arduino board, meaning it's an input pin because the Arduino receives data from the pin. The 3 LED pins need to be output pins, since we send some form of electricity, meaning we put out to the Arduino or to the LED, sorry, from the pins. Next up, we're going to be looking at the loop function in the Arduino IDE, which is the function which runs repeatedly after the Arduino has powered up. First off, we need to declare the switch states, which is a digital read function. With the digital read function, we can read the data coming from the switch, which then gets put into the variable of the switch state, which was the variable we needed to determine if the switch was pressed down or not. Next up, we're going to be using an if function to check if the switch state is low, aka it's not being pressed down. Now, if the state of the switch is low, aka the switch is not being pressed down, we can use the digital write function to determine which of the LEDs gets electricity. This function works by declaring the pin of the LED and either low or high, depending on if they need electricity or not. If we write high, the pin gives the LED electricity, or if we write low, it does not. Now that we've declared which LEDs gets power when the switch is not pressed down, we also need to declare which LEDs gets power when the switch is pressed down. To do this, we'll be using the else function, which is a combination of the if function, but the complete opposite of the start of the if function that we started with. So since we checked if the switch state is low at the beginning, else means that we check if the switch state is high or anything else. So, to get the flickering effect that we need the red LEDs to have, we also need to implement a delay. This delay comes in both before and after we write the digital write. So, now that we've written the code, we have built the circuit, we need to transfer the code from the computer onto the Arduino board. So to do that, we also need the USB 2.0 cable, as we did in the first video. We need to connect this to the Arduino board, as so, into the computer. And we see here at the top of the Arduino IDE, see the Arduino Uno is being connected. We need to press this, and then press upload here on the Arduino IDE. There we go. So, and we see here, it says done uploading and compiling. Now, if we take a look at the Arduino board, we see the green LEDs turned on as we wrote in the code. Now, what happens if we press the switch? See here? Like we wrote in the code, when we press the switch, the power or the pins stops going to the green LED from the pin number 4, or number 3, sorry, into differently the pin number 4 and 5. So, very exciting. You've built your first kind of more in-depth project, and you can more also maybe go into building some project on your own. I will also, there's a little bit more in-depth projects further on. So, why don't we just go into the next video.